Okay, so we've covered the introduction to the hydrographs. We talked about the unit hydrograph and generating a unit hydrograph from actual data. Went through an example problem of doing that and then applying it. So now I want to talk a little bit about synthetic unit hydrographs, which if no historical records are available to generate the unit hydrograph, you can use the synthetic unit hydrograph as a reasonable approximation. Now there's several different methods available for this. I believe Snyder's was the original method, but now there's other methods available, Clark, SB, and then NRCS. And we'll be talking about NRCS quite a bit later on. But Snyder's synthetic unit hydrograph is also presented in your book in table 8.4.1, which I'm going to show here. So I don't want to go through this in detail because we're not going to use it in this class. We're going to be using NRCS, but I wanted you to see it so you have some idea of what's involved in these at this point. So you need some information about the watershed itself, the main channel length, the length of the mainstream channel from the outflow point to a point opposite the centroid of the watershed, and then these regional parameters CT and CP determined from similar watersheds. One of the big disadvantages of Snyder's versus some of the others is these CT and CP coefficients are hard to know what to use for those. You would have had to done like a study to determine what those are. There are some tables and so forth available to derive those, but most people don't use this method. But once you had those, you could calculate this TP and TR. If you look down here, you can see this is the hydrograph that's developed. It's a triangular hydrograph that just has this TP is, let's see, let me zoom in a little bit on it. So TP is from the centroid of the rainfall distribution, which is right here, essentially to the peak. It's essentially the time to peak. This capital T sub P is the time from the start of the hydrograph to the peak, and that's TPR plus TR over 2. TR is this rainfall duration. So essentially you're trying to plot out what does this triangle look like, and some of these parameters like T sub P will derive how long does this take, and then TB, the time of the base itself, you can see the formula for it right here. And then the peak, QPR, the peak runoff, which is right here. We can go up and see that's this parameter right here. So you develop some watershed parameters, you go through and you calculate all these different parameters, and then you can draw out what does the unit hydrograph look like. And most synthetic unit hydrographs are triangles or can be plotted as triangles. So that's essentially what Snyder's does. But again, we're going to be talking a lot more about this when we get to the NRCS methods in a couple of weeks or in a week. So how do we use unit hydrographs to create storm hydrographs? Well, we kind of did that in the example problem when if we have a constant intensity storm, we could multiply all the ordinates on the unit hydrograph by the total precipitation of the storm. That's what we did in the example problem. But what if we had a variable intensity storm? What if we have a storm hydrograph that isn't the same the whole time? Well, there's a procedure for that, and there's a handout for this also posted on the drive. And some figures. These are some figures from your book, where we see a simple rainfall hydrograph up here on the top. Precipitation P1, precipitation P2, and P3. So 3 different time intervals, 3 different intensities. What I'm going to do is I'm going to take my unit hydrograph, which is this figure right here, and I'm going to apply it, starting at the beginning of the storm, essentially to just this interval. So here's my unit hydrograph associated with what's going on here. And then I'm going to shift it over one interval and apply this one right here to the precipitation, the intensity that's falling here, and then again to shift it over here to apply it to P3. So 3 unit hydrographs all shifted 1 period each. And then I'm just going to multiply, because the unit hydrograph is for 1 inch of excess precipitation, I'm going to multiply by whatever the intensity in inches per hour was for this box to get the actual hydrograph associated with just that interval. So that's what's going on down here. So I'm going to multiply this all by P1. So P1 is going to multiply every ordinate on this hydrograph. And then I'm going to go down here and I'm going to multiply every ordinate on this hydrograph by P2. I'm going to add them all together. So what happens is I get something that looks like this down here. So let me see if I can show you this. So P1 U1, so here's the precipitation 1 times unit hydrograph 2, 3, 4, 5, 6. That's the actual hydrograph for that first hour. And then I have my shifted hydrograph multiplied by P2, so I can see P2 up here coming down like so. And then I have my third one, this one right here, multiplied by P3, and that's going to look like this. So I'm just adding those 3 together. And in that way I can take my unit hydrograph again, which is my tool, which is this, and just by multiplying by those precipitation amounts and shifting it back and forth, I can apply it to any stormfall hydrograph that I have. Okay, and then add them together. Okay, so we've done that one. Now we've got, what if I have a unit hydrograph that was developed for one duration of storm. So let's say it was a 1-hour storm. But now I want a hydrograph for a 2-hour storm or a 10-hour storm. So I can do that using what's called the SCurve method, which is shown in May's section 8.5. I'm going to go through it here in this video, but it'll make more sense once you've actually applied it to some data, which you'll do in one of your homework assignments. So up here we see this is our rainfall duration for the hydrograph we have. T sub r is the duration. And this right here is the unit hydrograph for a storm of that duration. Now let's say I want a unit hydrograph for a storm of duration T prime r. You can see down here, this is T prime r. It's a different duration. So what I'm going to do is I'm going to take the unit hydrograph for storm of T sub r, and I'm going to shift it over a duration T sub r. So I can see here these start at the same time. Now I'm going to shift it over. This next hydrograph starts at that time, and I'm going to keep doing that forever and ever. I'm going to have all these hydrographs sequenced one right after another. Then I'm going to take the sum at each x coordinate, at each moment in time. I'm going to take the sum of all the hydrographs that are there. So, for example, at this moment in time, I would add this hydrograph, this one, and I'd get this value up here. As I go throughout time, eventually I get to this point where I no longer have an increasing amount, right? This is the sum of all of these, and it's just steady state all the time. Okay, so I wind up with this curve, which is the sum of all these hydrographs that have been sequenced. Now I go down here. I'm going to take that curve, which is this one right here, and I'm going to shift it to the right a duration T prime r, which is the new duration I want. Okay. Then I'm going to subtract these two from each other. So for each time ordinate, I'm going to subtract this curve from this curve. And what results is this graph right here. It's a hydrograph of volume T prime r divided by TR. Okay. Last step, I'm going to take this one and I'm going to divide every ordinate on it by T prime R over T sub R. Alright, so those are the steps. This now is a unit hydrograph for a storm of duration T prime R, which I got from a unit hydrograph from a storm of duration T sub R. Okay, so again, you'll get experience doing this in an upcoming homework problem. So now you have all the tools you need to go from a unit hydrograph, whether actual or synthetic, to a actual storm hydrograph for any kind of storm. Variable intensity storm, it could be different durations. And that's what we want to do, okay? What we'll be going into in the coming week or two are the NRCS methods, which we'll use to develop synthetic hydrographs, but also develop rules to then handle sort of the total volumes of runoff that are going to result from these storms, and then move into designing for those. Okay? So that is all for this lecture.